A and B are separated by a distance of 200 meters in their initial positions. Ball A is thrown vertically upwards with a velocity of 30 meters per second. And at the same instant, ball B is thrown vertically downwards with a speed of 20 meters per second. We have to find the time taken by A and B to meet at point C. Let's solve this problem directly using the concepts of relative displacement, relative velocity, and relative acceleration. We first fix the frame of reference to A. So now we will assume A to be at rest and that A is the observer. Then we obtain all the information about B in terms of A. What is given is that the initial displacement of A is 0 and of B is 200 meters. The initial velocity of A is 30 meters per second and of B is minus 20 meters per second. Minus since B is projected with a downward speed of 20 meters per second. The acceleration acting on A and B during their flights is the acceleration due to gravity, so minus g. Now this is as seen by an observer in the ground frame of reference. Now let's see this from A's perspective. Now in its own frame of reference, A is considered to be at rest, and this is how A sees B approaching it. The initial displacement of B with respect to A is 200 meters, and the final displacement of B with respect to A is 0 since they end up meeting. The initial velocity of B with respect to A will be Vb minus Va, or minus 20 minus 30, which is minus 50 meters per second, which means that A sees B approaching it from the negative direction of the y-axis, and the relative speed is higher since they are approaching each other. The relative acceleration of B with respect to A is 0 since they have the same acceleration, which is minus g, and this will definitely help us in simplifying the problem. Now we will have to put these values of B with respect to A into the equations of motion to find out the time required for A and B to meet. Without the use of pen and paper, let's think about what really happens from A's perspective. B is 200 meters away initially, and it is approaching A with a uniform speed of 50 meters per second. So we could solve it mentally and say that it should take 4 seconds for B to meet A. Now let's put these values into the equation and solve it. Plugging in the values of the initial displacement, the final displacement, the initial velocity, and the acceleration of B with respect to A, we obtain the value of time as 4 seconds. And you can see that the last term, half 80 squared, would be 0 as the relative acceleration is 0, and that really reduces the number of calculations. And now you can begin to appreciate how quickly you can analyze problems of this nature using the approach of relative motion. And we have followed exactly the same steps each time.